Hello, everyone. Welcome back to another type of bivariate analysis. It is called ARNOVA. I will keep this video short. We will introduce a statistical technique that allows us to examine all groups or samples simultaneously. It is called analysis of variance ARNOVA. So ARNOVA is an inferential statistic technique to test for a significant relationship between two variables in three or more groups or samples. It is different from t-test. T-test only covers two categories. ARNOVA tests if there were more groups different from each other significantly in one or more characteristic. So the one-way ARNOVA is also referred to as a between subjects ARNOVA or one-factor ARNOVA. Although it can be used with an independent variable with only two groups, we typically use t-test, right, to test the mean difference between two groups. So for this reason, you will see the one-way ARNOVA is described as a test to use when you have three or more groups, rather than two groups. So for example, your dependent variable will be exam performance, measured from 0 to 100 points. And your independent variable would be test anxiety level, which has three groups: low stress students, moderately stressed students, and highly stressed students. We could use one-way ARNOVA to determine whether exam performance differ based on test anxiety levels among students. As another example, your dependent variable would be salary, and your independent variable would be degree subjects, which has five groups: business, psychology, biological science, engineering, and law. So in this case, a one-way ARNOVA could be used to understand whether there's a difference in salary based on degree subjects. So we have introduced t-test to assess the difference between two sample means. And with t-test, we could analyze only two samples simultaneously. But here we collect a random sample of 100 people and group them into four demographic categories, including whites, Black, Latino, and Asian. We are interested in testing if there's a difference in educational attainment among the four groups. We would have to analyze the mean educational attainments of whites and Black, white and Black, Latino, and Asian. White and Asian, white and Latino, Blacks and Asian, and so on. So we have to analyze 6 different pairs and have a series of t-test calculations. But we still cannot answer our question if there's a difference in education attainment among the 4 demographic groups. So besides running multiple t-tests on all groups means it leads to an unacceptable increase in the type 1 error rate, which leads to incorrectly reject your null hypothesis. Okay, we are still going through the hypothesis testing, but because you are familiar with this from chi-square test and t-test, so I will go through it quickly. So ARNOVA requires several assumptions regarding the methods of sampling, level of measurement, and shape of the population distribution, and the homogeneity of the variance. So in order to run one-way ARNOVA, there are 6 assumptions. The first 3 assumptions related to a choice of your design and the measurement you choose to make. The second 3, the 4, 5, and 6 assumptions related to how your data fits the one-way ARNOVA. I'm going to leave it to you to read the assumption if you are interested. So it's important to remember when you run one-way ARNOVA, you are trying to determine whether the group means are different in the population. Null hypothesis is about the population parameter instead of the sample statistic. I repeated this question like many times. I just want to remember the null hypothesis is about population parameter instead of sample statistic. So you assume the null hypothesis, which states there are no difference in the population means between these groups. Another way of saying is that the group population means are equal. Using our sample data, we are trying to find evidence against this null hypothesis and accept the alternative hypothesis, which indicates that there are differences between the group population means. Another way of saying this is not all the group population means are equal, or at least one of the means is different. Next, significant level. Please refer to the t-test video and the p-value video to learn more about this. It's the same contents. Okay, next, we select a sampling distribution. For 3 or more samples, the null hypothesis is tested with a new ratio. It's an F ratio. Like t-test, F has its own sampling distribution to test the null hypothesis. So the resulting test is F test. We use the F distribution and the F test to test the difference between 3 or more group means. This is a knowledge you can memorize. Let's talk about the characteristic of F distribution a little bit. F values range from 0 to infinity. It can never assume negative values, no negative values for F. The shape of the F distribution depends on degree of freedom. From the figures in this slide, we can tell the shape is generally right good. So ARNOVA ARNOVA does not have a one-sided or two-sided option. F distribution only has one tail. Okay, this slide is a corresponding values of the F distribution for various degrees of freedom. And the level of significance is 0.05. Again, this is the knowledge like chi-square you can use to refer to the table to get the value. But you can always get it easily from the software. This is a formula for calculating F statistic, but again, you are not required to remember this. Your software SPSS or R can help you get the F statistic. A larger F statistic means more between group variance than within group variance. A larger F statistic increases the chance of rejecting the null hypothesis. I'm going to skip this technical part. So F statistic is obtained by the ratio of the mean square between the mean square within. By calculating mean square between, we can estimate between group variance. By calculating the mean square within, we can estimate within group variance. So the formula here determines the ratio of between group variance to within. This formula here determines the ratio of between group variance to within group variance. I attach appendix here to show you the logic behind ARNOVA, but it's not required for this course. I just want to put it here if you are interested to learn more, but it's not required. Okay, this slide shows an example of the SPSS output. Social workers always use SPSS. So you will see all the numbers like F value with degree for freedom 1 or degree for freedom of 2, and then P value. Again, making a decision to interpret the result. I want to show you the next slide about how to interpret your findings. This is a sample of what you may see for ARNOVA findings in the paper. One way ARNOVA was conducted to determine if the dependent variable was different for groups within group 1 with your independent variables. Like participants are classified into different groups, group A, group B, group C, group D with a sample size. And the dependent variables number will increase or decrease from group A to B to C or to D. And then you already see sentences like this. So this is how we report the differences between groups, whether it was statistically significant. Another sample here, you may pause the video and see the one way ARNOVA was conducted to determine if the dependent variable was different for groups with your independent variable, and the number is increased or decreased differences between group A, group B, group C, or group D. So the p-value associated with the p-value here is smaller than 0.05. This is the number you should remember, the p-value. So you report your dependent variable score here, and which means it's statistically significant difference between the groups because the p-value is smaller than 0.05. So if the F statistic doesn't advise on which groups are different, they just tell us there are group difference, but we don't know which groups are different. We can only tell whether your dependent variable is significantly different by groups in your dependent variable. However, it is rare to know where the differences are between the groups. So you can use another test, or when you read papers with this test, post hoc test, this is a common way to test for group differences. It is general because few students or few scholars set specific hypotheses about the group differences before collecting or analyzing the data. Okay, so I'd like to give you some ARNOVA checklist in case you are going to analyze the data by yourself. So you should ask yourself the following question before considering use ARNOVA. First, are you testing the relationship between a categorical variable and a continuous variable? In other words, are you trying to compare means of 3 or more groups? And second, is the outcome variable approximately normally distributed? The outcome variable should be normally distributed. And 3, are the observations independent of each other? See, if your answer are yes to all these 3, so you can use one-way ARNOVA. Okay, so we quickly walk through the ARNOVA, and for the next video, you are going to learn about correlation.